Welcome to Krebs Kitchen. I'm your host Jessica, and today we'll be making energy through the citric acid cycle. Look what I found. In my grandma's attic, I came across her secret recipe book. Shh, don't tell anyone. I'm going to share this process with you. To begin with, we need to add energy into the system. Step 1 combines acetyl-CoA with 4-carbon acceptor oxaloacetate to form citrate, a 6-carbon sugar. In step 2, citrate is then converted into isocitrate. In this step, one water molecule is extracted and then reattached to produce isocitrate. In step 3, the isocitrate is then oxidized. Carbon dioxide is released, creating a 5-carbon molecule. Isocitrate dehydrogenase catalyzes the reaction, and NAD+ is turned into NADH. Alpha-ketoglutarate is formed. In step 4, alpha-ketoglutarate is oxidized. Once again, NADH+ is transformed into NADH. Carbon dioxide is released. We now have a 4-carbon molecule that attaches to coenzyme A, creating succinyl-CoA, which is an unstable molecule. Now, we're halfway through, and I apologize. This recipe calls for lots of adding and subtracting of ingredients, but according to Grandma, it'll all make sense at the end. So for now, everything has to be done in a precise order. In step 5, succinyl-CoA gets replaced by phosphate. This transfer allows for ATP to be made. Succinate is produced, which is a 4-carbon molecule. In step 6, the succinate is oxidized, allowing for the 2 hydrogen atoms to be released. 4-carbon furamate is produced, and 2 hydrogen atoms, in addition to their electrons, are transferred from FAD to FADH2. Oops, not again. It looks like we're left the water out again. Since we just removed it, now we got to add it back for the furamate to transform into malate. Malate is oxidized, transforming back into the starting substrate of oxaloacetate. This causes a reaction of electrons from NADH+ to be moved to NADH. For the serving size, it's going to yield 1 turn of the citric acid cycle. So listed below, we have 2 carbons from acetyl-CoA, 2 molecules of carbon dioxide are going to be released, 3 molecules of NADH, and 1 molecule of FADH2 are formulated. 1 molecule of ATP is generated. The glucose produces 2 acetyl-CoAs, multiply that by 2. And through glucose pyruvate oxidation and the citric acid cycle, there's ultimately between 30 to 32 ATP that are produced. Thanks for stopping by, guys, and the citric acid cycle is now complete and ready for you to enjoy.